Welcome, everyone. You were tuned in with myself, Mr. Scott Lylander, and we are here with Cody Heibert of Harbottle Audio talking about the magic of Harbottle, the magic of audio, what makes these speakers special. And I met Cody in the digital domain, and my secret sauce is that sound is a human connection. And when you get the perfect sound and you get the tingling sensation and goosebumps, you know that you've created a connection with the sound. But there's also hanging out with people like this, people who can talk about audio and sound all day long. And I'm going to hand it over to Cody to introduce himself and Harbottle Audio.
Thanks, Scott. It's great to have a long duration interview with you. I am Cody. I am the president and director of Harbottle Audio Limited. Um, we specialize in bass, predominantly subwoofers. However, that language I found translates over into loudspeakers. So we're looking to break into some loudspeaker technology. And we're currently kind of finding our way and how we're going to express that. And we're based out of Canada, Edmonton, Alberta. All our manufacturing is in Canada as well, and in Alberta and British Columbia. Um, yeah, we employ local people. We work very closely with Funk Audio as well. I've worked with Nathan Funk for the better part of 15 years. And with our small little team, we really focus on high quality sound and trying to express what the science is in real terms that people can identify with and latch on to, because I, like many audiophiles, was jaded at one point just from all the jargon and trying to figure things out and things not working out for me. And I come from that background, and I found ways to fix it just through hard work and study, really.
Yeah, well, I can't wait to dig into some of those hard topics. But before we do that, why don't you tell us about the Hard Bottle lineup and what products you have available for retail and how those are sold?
So we have an internet direct line. It's called the Carbon series. We have a 5 channel audio system. It's essentially a no compromise look at what audio could be, minus all the fluff. Is aimed straight at performance. It's just a holds bar approach, really. It it features our C7 and C7M speakers, along with the C7 II tower speaker. They're ported. The idea is that if you want to run a subwoofer, you totally can. But if you're like many people that love music and don't really see the need to dig below 20 hertz, then why do I really need a subwoofer? I know a subwoofer adds a lot, but do I really need it? It's that kind of question that people latch onto. And this is a solution for that, where if the room supports it and it's of a respectable size, you don't really need a subwoofer. And that allows you to stream a lot of content without the need of going to a subwoofer, but you still have all the high fidelity for any movies and music that you want to listen to, especially if you're more music biased like myself. You can dive right into that world and not have to face those questions of, how do I integrate this subwoofer? How do I make it work? What extra equipment do I need? And then if you want a subwoofer, you can totally add one to that. And then we have the 18-inch Carbon Series subwoofer, level 1, level 2, and the 24-inch Carbon Series subwoofer, level 1 and level 2. And that rounds out our internet direct. So you would buy that on a store, you contact me directly, you deal with this guy right here. And then we have Cassini, which is It's an answer to all the tough stuff when it comes to home theater. It's a subwoofer only lineup. And when it comes to home theater with like waveforming, direct art, all these new technologies that are coming out, there's integration questions that always crop up. And what we're trying to solve is how do I get high quality audio out of my home theater or home audio system and get the integration lined up so everything works as it actually should. And so with Cassini, we actually have certified representatives. And I call them certified representatives because their role dictates that they have to have a Harbottle based system, a complete Harbottle based system, which they all do. And they have to work with me directly and also be certified in home integration techniques and different certification courses and classes and all of that stuff. They have to hold all of that. So we've got guys that are certified in Trinov and HAA and all the different levels that go along with that, as well as being really adept and knowledgeable in the language of Harbottle audio. And those products are available through those certified representatives. I do work with them very closely, but they are a solution to make sure that the client gets exactly what they're looking for. It's according to a design as well, like everything's spec'd out properly from square one, no guesswork. They are going to get this SPL minimum. Anything south of that, no dice. That is a minimum. And then from there, it just gets bigger and better. And those are the essential ways that you can get our product. We do have some DIY offerings for, high-end DIY enthusiasts. And then we do have some expansion lines in Cassini coming out with Cassini Tradition. And then there's a bookmark for a Cassini Heritage, which would be like a tip of the cap to where we came from and our history over the last 15 years. And Cassini Classic is just a different physical look. It's a classic look to home audio. It essentially features 19 millimeter radius corners on all of our subwoofers. Cassini Tradition is more of a square corner with a 3 millimeter radius, nice and tight. So more of a traditional look, classic look, and then we've got the crazy carbon series stuff. Within the Cassini lineup, we also have a really high-end line of carbon series speakers. They're called the Elite series. Those are the Bugatti Chirons. They're everything that I can do to make something beautiful. Like, we don't hold back on finishes. We use the same clear coat that Bugatti uses, Rolls-Royce, all those high-end cars. We use the same clear coat as those cars. We have like 40 to 100 hours just in polishing. Like, they come out like mirrors. They're just absolutely gorgeous. It is a no restraint situation. And the performance matches. Like, they go unbelievably clean, loud, compression free, highly efficient. They will do everything and they will blow your head off at the same time. They're just the maximum of what we can do in engineering. And that pretty much lines everything up for what we do. I know it was a bit much, I guess, hey?
No, that's what you're here for. That's the Harbottle plug, and I'll just share, if you want to go interdirect, sales direct, internet direct, go to harbottleaudio.com and you get a hold of yourself for distribution. Is it North American wide?
North American wide, uh, global as well. I handle all the global work personally. I'm currently dealing with a couple of clients in Australia and Slovakia, UK, Germany, Austria, we kind of go everywhere that we're wanted, and we have the ability to ship globally.
That's great. And from a previous conversation, and I understand that you've been a student of sound since 2010, and Harbottle has been a business entity since 2016.
Yeah, that's correct. I started learning audio science out of necessity. I was hired to help a business um, owned by Nathan Funk. I was hired to help him grow his company, and my approach was that, well, if I'm going to grow something, I need to know what it's about. I need to know how it all works. And so I just started learning, and I was a musician in my youth, and I um I learned really hard and fast, that listening is a critical part of of music, and it directly attaches itself to life. Like music and life are almost synonymous with each other. It's you go to a wedding, you're celebrating life, there's music, there's dancing. All of these things are intimately connected with the human experience. And that's something I gravitated towards your channel, Bon, was drawing a connection to the human experience. And so the need for um things that sound real, like fidelity, essentially, making it sound real and true is a critical thing. And when I was learning music and learning audio, I found out very quickly that those aspects of reality create immersion. They allow you to get lost in a moment and really savor and enjoy what you're experiencing, either on an emotional level or an intellectual level or whatever it is, that immersion makes it a very real connecting experience.
I agree, and I just think that when you have music on, it almost ups your level of creativity. It stimulates your brain, and
Yeah.
you just get inspired by music. And 100% agree, music is life.
I,
So how does Harbottle get the maximum performance out of their loudspeakers?
what we do is we tackle efficiency. Now, efficiency needs to be defined. We need to attach it to something. So, um, efficiency generally is thought of as a decibel per watt value. However, that decibel per watt value needs to be expressed in more definite terms. Like it's true to a certain extent, but it's not the entire picture. And so what most people end up with in previous conversations, even with yourself, is you'll you end up with a system and you think, oh, this is going to be great, but then in some aspect it falls flat and it doesn't quite deliver the way you hoped. And what I've been able to determine just through a lot of study and hard work is that efficiency in in terms of physics um is the preservation of energy. It's keeping energy where you want it to be and not letting it escape in other places and go other directions, right? So like I know you're a motorcycle guy, Ducati. I appreciate the Italians. It's very nice.
You betcha.
You get that perfect tune on that motorcycle. You know what it's going, you know what it's capable of doing, and you know how it's going to deliver that. And as soon as something becomes as something goes out of spec just a little tiny bit, like it starts to wane, now there's something wrong with the performance. Like it's still there, but it's not quite right. And so the way we measure that in sound within our company is the first decibel of compression. Compression is when you double your power and you get 3 dB back. And then you double it again and you get 3 dB. Then you double it again and you get 2 dB. That first dB lost, that's energy gone. It's now gone. Where did it go? Because when you're doubling your power and you're getting 3 dB back every time, that is linear performance in amplitude. So it gets louder and it's predictable. And you know and understand, your brain can make sense of it, that, okay, when I double my power again, I'm going to get another 3 dB and it's going to sound like this. But when you lose that decibel, or when that decibel loss becomes audible, well, you have to
Let
ask,
me
where
guess,
did that,
that's gotta be compression. You're losing it to compression.
you're losing it to compression. Now, there is power compression in amplifiers, which is true. But what we're talking about specifically is compression in SPL in the speaker driver itself. That's what we're focusing on. So the places where, just a few of the places where that energy can go is you can have elastic losses in the suspension. So you got your surround and you got your spider. And the further the driver moves, the more the cone moves from its center point, like its center point's here, it moves away and comes back. The further it moves, the more tense those suspension parts become. And based on how their compliance works, because they work through a range of distance, at a certain point, they will start to render ill effects. So you can have elastic losses, and then you can have thermal losses. And that's the one that most people gravitate to when they think of compression is, oh, my driver's getting hot. And so it's thermally compressing. And that one is very true, definitely. And it has its own host of issues that go along with it. However, you can also have compression losses or efficiency losses in the magnetic field. In other words, the magnetic field, where the big magnet is on the back, through the inductance linearity of the coil, the magnetic field can, because that coil is tracking through the BL curve, like it's it's literally a magnetic field and the coil is moving through it. Okay, so as it's moving through, you have to ask how well saturated that magnetic field is at every point along that stroke, and more so, how concentrated and linear is that magnetic field. And so you can have magnetic losses at various points in the stroke just because the magnet is not linearly magnetized. It can produce weird effects through the magnetic gap in the motor itself. And then you've got motor geometry. So the actual dimensions of the magnetic gap and the dimensions of the motor and the dimensions of everything as it's machined and built, you can have other losses in there. And those don't all directly translate to heat. They can translate to things like intermodulation effects, distortion, and compression. We know intermodulation compression exists because intermodulation distortion exists. That's when you have multiple frequencies playing at the same time. And when it's distorting, you have extra frequencies that aren't supposed to be there. Like if you have 5 frequencies and it's supposed to be playing 5, and then all of a sudden you have 8. Well, the sonic signature of the thing that you know well now has 8 frequencies instead of 5, and so it sounds fake. Like
Eh,
it sounds like a wood carving of itself. It's like it's not real. right? It's
And
like,
that's because the woofer is not moving in fidelity with the signal because it's compressing, it's distorting, and therefore a change in your time domain waveform is going to result in different
yeah,
Fourier frequencies. And that's where you're talking about this modulation of different frequencies. That's very interesting.
yeah, like intermodulation is modulation within itself. So something that needs to be modulating well within itself has frequencies happening inside it in tandem with itself. It's intermodulating. So you end up with essentially the simplest way to look at it is with the loss of efficiency, you now have the inability for the driver cone coil moving parts assembly. You have the inability to articulate all the details and frequencies that should be there. And so when you start compressing, what I notice first, and when I talk to my clients and we've had long discussions and I've asked them to do certain tests and check things out, the first thing they say they notice is that the detail drops. It starts to go away. You start listening at a fairly low output level, and all the detail seems to be there. And you turn it up, 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 and all of a sudden the fidelity drops. The detail just starts to diminish, and things sound dull and lifeless. And then you drive it even harder, then it sounds thick. And it's like it can't get out of its own way. It's like kind of like sprinting covered in tar. But because it's modulating, the level of tar that you're completely encased in is, changing. Like, 1 second you'll have less tar, and another second you'll have twice as much. And so your ability to run is completely inhibited, but it's modulating. It's always changing. And that's what compression does in content. It becomes hard to track until it gets to a point where it's depreciated so much that the driver doesn't have any room to articulate within itself. So it sounds like it can't even get out of its own way anymore. And that's typical in home audio. In pro audio, generally what happens is a pro audio driver is designed to work in a pro audio environment, number one. So you think of a public address environment, well, that's loud as the thing can go for as long as it can go, and have it not blow up. So have it, somewhat reliable for a duration of time. Pro audio in a domestic environment is a really hard transition because it's got really stiff suspension. The motors are super crazy built for to be as sensitive as possible. So they're able to get blistering SPL with relatively modest power, all of these kinds of aspects. And so most pro audio, like, it will sound good in a certain range, but most of my clients that have switched out of pro audio gear to my gear, like 99% of them, except for one or two people, who said that they really didn't know how much detail was there. Like, in theory, you can get all the low frequency. You can run a pro audio driver and a large low tune subwoofer, and you can get tons of low frequencies and everything out of it. And it can, but the detail isn't there. And that same principle applies to every kind of loudspeaker, because every loudspeaker has an impedance curve. And it depends on how you want to drive that impedance curve above and below, or how you want to drive that speaker above and below that impedance curve. Like, do you want it to work below its impedance peak? Because that's where you're getting into the need for stroke. Is it even designed to operate below its impedance peak? And there are telltale signs that, you can definitely, see in an impedance graph and in a frequency response graph just by correlating a couple points of information. And even that can tell you, what amplifier to get for your speaker. So,
So I just got to say that we had this conversation a week ago, and I I said there's a need to record this because this information, I think it's golden. I'm learning. I love to continually learn, and I think you just explained that really well.
oh, thanks. It's a process trying to articulate this stuff because the way I think of things, it doesn't usually translate every single time to all people. I appreciate that feedback, man. That means a lot.
Well, and there's a few things that sort of stuck out for me. Was the efficiency of the motor. And I know that you can have a horn loudspeaker, which increases the efficiency through horn amplification, but it's interesting that the motor is also designed for a particular efficiency. And also, do you want to drive your speakers, your loudspeaker capable of operating below the impedance curve, or are you relying on the box amplification to cover that range? That's
Yeah.
super interesting.
Bingo. Bingo. Like, what speakers do you have again?
The
The Tannoys.
uh, I have many. Of course, I'm an audiophile, but we've been talking about the Tannoy HPD 385. Now that's 385 for 385 millimeter, which is a 15-inch diameter loudspeaker. They're dual concentric with the tweeter, the pepper pot tweeter in the middle, the bass driver essentially acting a bit of as a horn waveguide and also creating a single point source. Now, I bought these because they were the best speaker I've ever heard for detail and imaging. And I know that my friend had a serious amount of power, a serious, amazing front end setup. And I'm not there yet in my system. And I've just been like, what do I got to do next?
Do you want to know?
I do.
I can pull up a graph. I've looked up a graph here. I'm gonna just share it. All right. So, um, this is Moxtone Lab. I just literally Googled it and pulled it up. Tannoy HPD 385 15-inch. This is back in 2007. Is this roughly it?
That's the driver.
Okay.
Definitely, I've got an Onken 360 liter style enclosure, a fully custom crossover, and a Lockwood hard edge conversion kit.
So is
So
that
there,
is that's kind of like a transmission line enclosure, right?
that's correct.
Okay. All right. So this is what I found interesting in the graphs here. You can hover over all these graphs and you can see many different things. The graph of the impedance peak, um, it looks to be as though it's free air. It's the impedance of the driver of the woofer wants to get up to about 225 ohms, which is a lot of ohms, but we're not really interested in that. We're interested in what it's going to do in a box because look at that, the box matters. So around 50 or so hertz, 55 hertz, it jumps up to about 50 ohms, 53-ish, if you want to split hairs. And then it drops and then it has a impedance peak again at about 10. I'm not really interested in what's happening in 10 because we can look at the um, frequency response of the woofer in the box and we know that it's rolling off well above 10. like 20, 30, 40, 50, 60 hertz. It's relatively flattish in this zone. So we're not going to get 10 hertz out of that, out of that driver. No way, no how. And then, of course, frequency response of the woofer, assuming free air, doesn't really say that, but that supports that as well. Probably an infinite baffle, and from 100 down, it starts to roll off. So what we're going to do is I'm going to show you what I do with my clients when we're talking about where to match a subwoofer with a loudspeaker. But in this case, I'm going to apply it to what amplifier do you use to drive these things. And what we're going to do is we're going to relate the impedance peak right around 50 hertz to what we know is happening in the frequency response. And right around 50 hertz, we see it starting to fall down. So there is something happening at around 40 hertz. It's starting to want to pull up again. But we have to ask ourselves, is this driver, just looking at the frequency response, is it a candidate to be a 40, 50 hertz bass driver? Well, by its roll off, I'm going to say no, because its ability to generate fairly linear frequency response SPL, dB SPL, right here, that's our amplitude, it's starting to be compromised. Okay. And we're already losing, about 10 dB by the time we get to 40 hertz. So it's not a deep bass driver. By this graph, I'm going to say we're probably looking at around 60 hertz as a usable low end. Now let's equate that to what's happening in the impedance peak. At 40, 50, 55 hertz, the impedance peak jumps up. And that correlates with the 40, 50, 60 hertz, 55 hertz right here where it's starting to roll off. So below the impedance peak of this driver, it is not able to articulate anymore. It is literally dropping down in amplitude. It's not, this tells me that it's not really designed for stroke, because below the impedance peak, that's where you're going to start to stroke limit the driver. The driver needs to be able to articulate and move around. That's why ports exist. I'm trying to extend the leverage. A port is a lever. Same with a transmission line. It's a lever to extend the low end frequencies and try to lift this zone right here, trying to lift it up a little bit. And in this scenario, no, it's not a good candidate. So
Everyone, you just got a tremendous piece of a golden nugget there. Just continue listening to this guy. I love it. Carry on.
So now we need to know what kind of amplifier is going to get the job done. You said that they're a great loudspeaker when you heard them, and you've had some troubles driving them recently. So, we got to look at the ohm load. Well, unfortunately, the ohms are they're hard to track because there just isn't a lot of detail here. Like, it starts at 0 and then jumps up to 20. And grab some water. That's not a lot of detail. So what we need to do is we need to extrapolate what's happening. And right about here is 10. That's halfway. So we know that at 10, it's going to dip below 10 nominally. And we know that by the frequency response, probably not a good candidate to drive below 50 or 60 hertz. So we're going to look above 55, above this impedance peak, because we don't want to stroke limit this driver. It's not designed for it. It shows no intention of being good down there. And where does the impedance drop? Well, we know we're going to be south of 10 at 100, 200, 300 hertz probably. we're going to be south of 10. So we're going to be really close to around 8 in real life. Now, what kind of amplifier is going to deliver power at 8 ohms? Well, an 8 ohm stable amp will, but a better option is going to be a 4 ohm stable amp. And now we need to ask ourselves, what kind of power do I need? Well, what is the purpose of a driver? A driver is to move around. It needs to articulate, flap around, and move really, really, really quick. And what moves really, really quick in electricity? Now, in the trades back in the day, I've been hit a number of times with electricity. And I can tell you that high amperage electricity is really scary because it just locks you up and you can't move. You just seize on to whatever is hitting you. Now, high voltage electricity with low amperage, that will actually cause you to jerk and like, you know, throw or like, kind of like toss whatever is in your hand. So electricity has this ability to be really grabby or really zappy. It's not technical, but those are the two realms. You have voltage and you have amperage. And volts are very, very fast. Nikola Tesla proved that with the Tesla coil. Um, Amperage, they drive really heavy loads. Like, how much amperage do you need to run or charge a Tesla car? Like there are two distinct differences in power. And so we need to normalize what we're talking about. What kind of power do you need? Because a watt is only theoretical. It's really a terrible way to measure electrical power of any kind, because this impedance peak here, right here,
Yep.
this behavior all the way up past 1K, that changes your watt swing.
Hmm.
Crazy.
Yes.
But what's more is that right here, you're going to have a completely different voltage requirement than you're going to have right here. And that's not even 1 octave away, like 50 hertz right there. That's 30, 40, 50. An octave up is 100. Octaves are really, really short. Like that's the measure, like the first octave, that's like the first step. It's like right there. So 50 to 100 hertz, short jump. That's not even 1 octave. And this thing has to swing down from like 53 ohms all the way down to less than 10. That's a change in your ohm load of 43 ohms. And the amplifier has to be okay with that inside that octave. And it has to repeat that over and over and over again with however many variations of frequencies are going to be reproduced in that zone over and over and over in combinations, amplitudes, durations that each frequency is held onto for, all of that stuff.
So
And
how do amplifiers spec this sort of performance? What are you looking for?
honestly, I I kind of gave up on amplifiers, and I stopped looking at anything that didn't publish a voltage rating, because when we're looking at impedance here, what we're seeing is a change in resistance. Well, what does that resistance change according to Ohm's law? It changes amperage. So the most stable thing in this entire equation for your speaker is going to be voltage. That's the stable thing. So the watt rating doesn't really mean anything because the amps are going to shift. So what you want to look for is a peak to peak voltage rating. So if the
Oh,
amplifier has, let's say, I don't know, 50 volts peak to peak on a speaker like this, probably pretty decent.
is that common for an 8 ohm or a 4 ohm stable amplifier?
Our amplifiers are 2 ohm stable, and we run 150 volts peak to peak plus.
What do you see in the consumer audio market on voltage ratings? Are you familiar with that or voltage
Well,
performance?
yeah, I'm fairly familiar with it. Generally what I look for is like a really good quality pro audio amplifier that will publish a voltage rating. So I see guys like, well, there's myself, but I don't make amplifiers for the general public. But there's, like VTV, Hypex will offer some of those type Hypex based amplifiers, Purify. Um,
Class D.
Class D type stuff, but in the audiophile hi-fi realm, we're going to be looking at Class A. The reason why is because Class A power is always on. It's always fully loaded. You're not going to get a ton of watts out of it, but everything that power wattage is capable of doing is going to be there all the time. And so for a lot of people watching this, looking at the Class A realm, yes, it's going to be maintenance heavy. There's going to be tubes to change and, all that kind of stuff. Is it ideal? Probably not. Barring that, you're going to a really big, heavy, high quality Class AB, and you'd be looking at spending quite a bit of money on it. What you essentially want is a Class AB that has a really hefty Class A stage, and then the switching mechanism to Class B, because they're two different topologies in the same amp. That switching mechanism needs to be really smooth so you can't detect it. And you want enough power. This is kind of where that ideology of getting lots and lots and lots of power comes from. You get tons of power in a Class A B. Hopefully, you get enough Class A power that you never really have to switch into Class B, except for under like really extreme circumstances, like super high bursts and all the rest of that. But now with the uh, uh, addition of Class D and the advancement of Class D, getting really good transistor tech in there, and power rail stabilization, DSP, integrated DSP, all of these things that specifically target high fidelity, you can get all of the good effects of a Class A amplifier with none of the drawbacks. So you can get all the fidelity and all the power, but you don't have the heat, you don't have the maintenance, you don't have the the high power consumption, all of that stuff. So there's some really good Class A or Class D amplifier options out there if Class A isn't something that you're particularly gunning for.
So in your applications, have you ever mixed Class A and Class D together?
I've run my loudspeakers on Class A, Class AB, and Class D. Um, my loudspeakers are very revealing, so they will show up a deficiency in a Class AB very quickly, especially in dynamics. Like the way my loudspeakers are initially, put out there to the world is that they're a critical listening speaker with a lot of guts. They have a lot behind them. The C7 II is a super full-bodied, full flavor, um, just full-on high performance machine.
And that's
So
that's the
when
floor
you
standard.
that's the floor standing, yes, the
Thank
C7
you.
tower. And so when when you're running power that, because it can burst in content really well. So when you have wicked transients and dynamics and subtle changes that need really quick articulation while there's a bunch of loud stuff going on, it can do all of that. The problem is that the um the ability to just keep running them into where they start getting into basically reserve power in the class B stage, that switching mechanism, if it's choppy or rough, it really shows up what that sounds like and can start to sound crunchy. So for myself, I prefer a class A or class D, like a good quality class D
Mm.
on my loudspeakers. And what I run right now, I actually built my own amplifier with all of our own parts. I call it the super amp, and I use it for testing and verifying equipment and doing R&D and all that stuff on. And we actually use Pascal based modules. So I know that some people have said, oh, Pascal is, it's not that great, blah, blah, blah. And that might be true for certain applications. However, what Pascal is really good at is operating above and below the impedance peak of the driver. And if you're asking bass out of your speaker, anything where the frequencies start to get long, and for me, like I honestly, I put, I start qualifying bass as anything below 150 hertz. Below 150 hertz, the frequencies start changing violently and rapidly. The rate of change is so unbelievable that the amplifier has to be able to be composed through that rate of change and handle the impedance curve at the same time and all the other nonlinearities that are going on. I think a big misconception is in audio, especially in the audiophile realm, is that a speaker needs to be linear. However, that's scientifically impossible. It has two environments. If it's got a transmission line in the way, it still has the environment in the box plus the transmission line and plus whatever is happening outside the box. So every time it moves, it's dealing with two completely different environments. It's there's nothing that's linear about it. There's changes in temperature and magnetic flux, and just look up Faraday's law, and you'll see how magnetism and non-ferrous materials react with each other. There's no way that BL should even be linear because it helps accelerate, yes, but it's a indication of power, instantaneous power or force behind the driver cone. But running a non-ferrous material through a magnetic gap also acts as a brake. It acts as a damping force as well. So there's a lot of things going on there. So, kind of addressing non-linearity in terms of, what fidelity is supposed to be. Well, there's certain non-linearities that actually need to be there. So it's targeting what the driver is best at doing. Like, where is its highest point of efficiency? And that is seen, still looping it right back to the beginning, that's seen where you start losing SPL in compression. That's the first measurable point every single time. And so if you focus on what the driver is capable of, where it's capable of doing it, just by even extrapolating a little bit from these graphs, you can land on a power application that will get you to where you need to go. And so whether it's my speaker or a Tannoy or a Focal or whatever, it doesn't matter because every speaker on the planet is capable of operating very well underneath a limit of compression. It's defining where that limit of compression is. And that's something that's not an industry standard. Like, we got impedance curves, frequency response, spinoramas, all of these things, but none of them address efficiency in terms of lost SPL. Where does it go? And where is it in terms of applied power? Like, how much power do I have to apply in order to start compressing? There are
And I
some,
mean, you could simply plot that on an XY plot and present that as
yeah,
well.
actually, yeah. Um,
And I just want to, I want to throw out 3 points here. What the first point is that we're looking at a Tannoy HPD right here. Definitely not my HPD, not my measured data, but at
no,
HPD. So we're just throwing that out there. The second thing is we just covered a lot of technical content, and I want to encourage people, if you found something that you've held on to that's been an aha moment, or maybe you just don't get it yet, I want to encourage people to drop a comment in the comments section, and Cody will check that out and definitely respond. I'll be looking at that as well. And we want to help everyone, I mean, make their sound beautiful, right? We want the highest fidelity experience because it creates the best human connection. So
yeah.
and then the third point, and we can go into this after your example here, you talked about how important the cabinets were. And I want to just drop that carrot and leave that for a minute and just say, what do you do in your cabinet design? Do you go flexible or do you go inert?
I go inert. I want my cabinets to be quiet. I don't want them to um really have any say in what the sound should be, because when a cabinet starts to contribute resonance, what you're affecting in resonance, because of, if we look at what a driver does, like when we look at FS, it's called free air resonance, okay? When we put that into a cabinet, that free air resonance through the impedance graph, that resonance changes. So like in the example of your tannoy, we had a huge ohm load and all kinds of stuff going on. And then he said that he put it in a cabinet and this is what he got out of it. And so the cabinet contributes to that. Now, my approach is, if I want maximum efficiency, I need the cabinet to resist and push back and hold everything in check so that the driver can do its job to the most efficient capability that it can do, that I can do that work with whatever content is coming down the pipe. So regardless of what's happening, the enclosure's job is to not interfere and just let the driver do its thing. All it's supposed to do is just support air. That's it. And some people want cabinet resonance, to contribute and to liven up the experience. And that's a totally fair point. There are people that love horns for their contribution to the sonic signature. And that's totally fine. There's nothing wrong with that. I'm not saying that there is anything wrong with that, or whatever. My point is that when you're looking at efficiency, the best way to understand efficiency in terms of compression in the driver is to remove all the variables to the maximum extent that you can. So without building like a concrete bunker for my speaker drivers, I do put a lot of engineering into our enclosures. I don't design enclosures, I engineer them. I use seismics, I use all kinds of structural information through my training in with physics, structural physics and vector physics and all that kind of stuff that I got in college. And yeah, I mean, it might be looked at as a little bit overkill, but the thing that it gets you is the ability to use the stroke of the driver without having weird impedance issues and weird fluctuations that shouldn't be there. Like everything is accounted for within the frequency response. It's all verified. And so that allows you to use stroke. And what I found for myself with especially with my loudspeakers is that the contributions of the low frequencies that add context to whatever it is that I'm listening to, whether it's a classical piece or, some, I don't know, music that my wife, puts on that's not necessarily my taste, but
Taylor Swift.
no, actually she doesn't like Taylor Swift. Um, it's just she she downloaded Miley Cyrus a while ago, and not exactly my taste, but the recording is actually a pretty good recording, and there's a lot of music there that I'm familiar with, instruments and that I understand. And so the ability for the speaker to drive down below its impedance peak and create bass gives the upper frequencies meaning and context. Like, I kind of liken it to going for a walk, and when it's windy, even though it might not be windy right around you at that moment, you can see and sense and hear aspects of the wind, but then it starts to buffet against you, and you understand the context of the weather that is occurring around you because you have that tactile feel of the wind hitting you. And same with like a big truck rolling by. Where I lived before, loaded with, 2-ton, 3-ton welding trucks and, welding rigs and stuff. And I could feel and hear big trucks coming before they even got to my house. I could feel it through the floor. And then a couple seconds later, I could hear them. And that gives those sounds context. Or else, if there wasn't that, infrasonic or bass subwoofer level um, contribution, all of those sounds that just show up all of a sudden get really surprising and alarming because the preamble for it isn't there. Like you don't have that tactile, like, okay, I understand that this shaking or, the wind or whatever that's happening around me. I need to go home, put on a jacket or, whatever, like, or something really loud is coming, like that context wouldn't exist. And so I found for myself that that's more valuable because it lends a sense of life to whatever it is I'm listening to. Like when I was playing drums when I was younger, I was a pretty rubbish drummer, and but I could tune things really well. Like I could tune my drum kit so it just sounded fantastic. And the thing that I liked about my drums is when I would play them, like I never had any pillows or anything stuffed in them. I just played them open with a batter skin and a resonant, and I'd tune them up really well to what the drum could do. And you get a really nice attack followed up with a nice big sustain after it. And that sustain gave the bass drum and the toms context as opposed to the snare and the mounted toms. I could understand and feel what's going on. There's a lot of feeling behind it. Even the shrill off the cymbals, you can feel that stuff when you're behind the kit.
So is this in context of having the driver be able to displace throughout this impedance curve that gives you more of this context,
That's right. And it applies
this
to
musical
tweeters.
context?
Yeah, it gives that musical context because it can swing through its impedance curve without any hindrance, and it's not losing the ability to articulate. So that applies to tweeters as well. Tweeters do have an impedance response, mid bass drivers, mid woofers, woofers, mid range. All of those speakers, they all have an impedance response. So that rule applies to all of them, and it's where those efficiencies line up so that, like in the other example, we could see the frequency response dropping off and the impedance rising. Okay, so we know that we're at a point where the efficiency is starting to wane. Now, what driver are we going to introduce to take over the load? Because this one is running out of steam. It's running out of room. So we need to look at that particular context of what the driver is capable of doing to its maximum ability, not in terms of just beating on it relentlessly, try to get every, dB out of it, but what it can do efficiently before it starts to lose efficiency by losing decibels. And when you look at speakers in that context, the ability to drive below the impedance peak, shut the front door on the enclosure so it can't contribute anything. Now you're left with a completely different context where the room becomes energized even at really low volumes. The SPL levels are fairly low, very reasonable, easy to listen to, and the room becomes energized because the effect that approach has in efficiency directly affects things like imaging, your sound stage, your off axis performance, your above and below axis performance, vertical, horizontal, and how wide the sound stage is able to operate. Like, for instance, a common theme, and you are coming up here in a while to have an audition. A common theme is that my speakers can image outside of their given soundstage. So you got, left and right, and there they are. And usually the soundstage is between the two. Well, mine sit off of that, and they'll typically, depending on the content, it moves around a little bit depending on content, but it can fluctuate out as wide as, 2 or 3 feet outside of the limits of the speaker. So things will track very, very far around the room. And that gives depth and layering to what you're listening to.
So you just reminded me of a particular track that I'm going to add to my playlist when I come up there to demo the Harbottle audio speakers. Can't wait for that. Up in Edmonton, Alberta. Um, I do have a question, and how does the sonic signature vary or differ when you limit the driver's stroke at the impedance curve or just above the impedance curve and you use the box to generate the bass?
Okay, so in the terms of, let's say, a transmission line or a ported enclosure, I'm not going to get into bandpass. Um, the the ported enclosure acts as a lever, so it's designed to extend what the driver is already capable of doing. The thing that needs to be remembered is that when you extend the frequency response of what the driver is already capable, and when I mean capable, I mean efficient at doing, so that same curve needs to track, like the way its natural roll-off happens in infinite baffle, you want that to be fairly close. If anything, you just want it to kind of straighten out a little bit and then drop off. You don't want to rise. If anything, you want it just to fall like very slightly and then fall off more quickly. That is the lever. And what that means is the driver still has to produce stroke.
And it has to do it
Yes.
linearly,
It has
predictably.
it has to do it predictably. Exactly. I love the fact that you use that. Predictably means that it has to do it without compression effects happening. So just because there's a port there doesn't mean that like if you have a 40 hertz port tune on a loudspeaker, okay, and the driver is very capable down to 60, and you're kind of trying to stretch it out a little bit, get a little bit more low end, try to hit that 25 hertz in room mark. Well, that 40 hertz port tune means that that driver still has to produce that stroke. So even if you're running full bandwidth, like wide open, no high pass crossover on your speaker at all to manage the port loading, that's probably a little bit complicated to to say, but essentially the port needs to be loaded with air. And so if you have a 40 hertz port tune and you're asking it to do 20, chances are that driver is going to unload. The port's going to unload and the driver is going to bottom out and start chuffing or making some weird sounds. Something is going to happen because that's not the design purpose. What you actually need on a ported enclosure is you need a high pass DSP or like a high pass filter that is a few hertz below your port tune. So if it's tuned for 40, go for 35, make it nice and steep. And that way you know that your port is still going to be loaded no matter what's going on. Now, getting back to how the driver responds and reacts, if you're asking low frequencies out of it below the impedance peak or below the port tune, what the driver still has to create those frequencies. It's not like they just show up because the port is doing it. The
They're
driver,
just amplified by the lever effect.
they're just amplified by the lever effect. Exactly. So the driver still has to produce stroke. Even though it's lower amplitude, you still have to produce fairly long frequencies according to what the driver is capable of doing. Now, if it's not able to work below its impedance peak very well or efficiently at all, driving a really low tune related to that driver just based on the frequency response, that's basically a fool's errand because you're going to be asking a lot out of that speaker driver that is just not able to deliver. And then you'll have a compromised um, audio system. Now, there are some audio designers out there that intentionally do that in order to round out the bottom end, but the entire design isn't centered on low end frequency response, low end output. There's safeguards put in place, and the entire speaker is more centered on, a fidelity aspect rather than high SPL. So it's not a high power driving speaker anyway. So even though you might be doing that in a quote unquote compromised design, you can still operate underneath the threshold of that 1 dB compression just by using your power wisely. So it doesn't mean that it's a game over if something doesn't exactly line up right out of the box. It means that the power applied needs to be done so effectively. And that's where things get tricky when, again, coming back to the wattage rating, it doesn't tell you anything. It doesn't tell you what power is actually happening. So like for volts to actually kind of lock horns in the industry, the speaker manufacturer needs to post a voltage rating for the speaker itself, right? So how many volts can this thing actually take? And what is the maximum, like what is the impedance curve on this thing and the lowest impedance on this thing? Like where does it all sit? Minimum impedance. Those are kind of the three things that need to happen. And then the amplifier manufacturer needs to post a, peak to peak voltage rating, an RMS voltage rating, and then a amperage rating, peak to peak amperage, or no, sorry, RMS amperage. And those things will tell you everything that you need to know as to how well a certain speaker will match up with a certain amplifier. That's not done, because I can see what would happen in the industry. It would become a thing where everything would be, it would be a little bit too easy, and you end up with a lot of businesses just flatlining because, what's perceived as, okay, well, this is what I want, will even be more tidal than it already is. Like there's a lot of very strong personalities as to, what is considered really good and what is considered bad and all that stuff. And the influencer landscape really shifts tides as far as loyalties to who and to what. And that can turn into a pretty messy situation. So I understand why that's not done, but it doesn't mean that you can't extrapolate some information like we just did with your speakers. We extrapolated some information, got a few things nailed down, and honestly, I'd say with your speakers, oh, you know, on Class A, give it, you know, give it whatever your budget can allow on Class A, and on Class D, for $1,000 on a power amp. Like if you went to a VTV, I'm pretty sure that you would be pleasantly surprised on a Pascal or a Hypex topology. I think you would.
I might have to just try that out, because how do you know how it sounds? Well, you can predict, but then you just gotta listen.
Well, that's yes, exactly. You can use information and extrapolate data and create a picture for yourself, but you still have to try it to make sure and verify, because you're still just trying to eke out bits of information to, you know, just to get a little bit closer to where you need to be, right? It doesn't
Mhm.
mean that it's a lock, you know,
And of course, your room acoustics matter tremendously.
hugely.
Your
Absolutely.
setup, where you put your speakers.
Yes, definitely.
Um, Now, I gotta do a shout out here. Okay, so I know that Miley Cyrus throws out some amazing tracks. I love a lot of her covers. I do enjoy Madonna. Hey, if you like it, you like it.
Yes.
I know there's a lot of Swifties out there. If you like it, you like it. But what does rounded bass sound like?
Effortless.
No, 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 no. So what you said was that some speaker manufacturers in a compromised design will round out their bass. I'm kind of thinking maybe that's to accentuate it, but there, when you do that, it's no longer tight.
Okay, in that context, you can only go so far before you get into a situation where the driver can damage itself like way too easily. So you have to round out the design within limits. Like you can only get so close to destruction before it actually destroys itself.
Hmm.
So when you're rounding out the low end and you know that you're quote unquote compromising the design, what that means is that there is going to be a power limitation that's going to show up earlier than you probably would expect, especially in the low end. So you have to look at what the speaker is designed for. There's an intended design behind every speaker, like what the engineer wanted, and then there's the design result, what they got. And behind that intended design is laid out in the goals. of what that's supposed to be. So when you're rounding out the low end, what you're trying to do is you're trying to make sure that you're getting the best of all worlds within a threshold limit. And so when I said that it sounds effortless, that's what that means. It still sounds effortless within its range of operation. Everything has a threshold. It's not infinite. So I mean, if the speaker's got a ton of engineering in the mid bass, a ton of engineering in the mid range and tweeter, the crossover, the enclosure, whatever it is, it's got a ton of engineering in it. Where where are the compromises? That compromise is the limit. That's the first. That's generally the first limit that's going to show up. So whether it's a stroke limit or a power handling limit or a uh, uh, an an axis limit, like horizontally, vertically, and so that will limit positioning. So now you're looking at directivity. You're looking at how much energy is this thing producing within that window of directivity that will affect like reflections and all kinds of things. People run into these limits all the time because they're not appealing to listen to. Like that is the limit. So like I see guys on different forums and things where they have problems with integration, and it's a crossover issue that's you know well within reason, but it's a time domain limit because there's delay issues or there's impulse response issues that need to be corrected within a certain frequency response or within a certain bandwidth of the crossover. Well, how do you effectively correct for these things? And so limits can show up anywhere. And that's the tricky thing about audio, is that it's so dimensional, like multi-dimensional. There's like just within time, within a speaker, there's 2 units of time. The frequency takes X amount of time to generate, and then the content tells you how long, or tells the speaker how long it has to hold that frequency for. So it has its own time that it takes to generate the frequency, and then it has the duration. And so there's 2 units of time happening here. And you can easily stack them both together, sure, but you're talking about demand on the driver. So now that loops back to, what is its intended design? What is it designed for? And where is its practical limit? And that's kind of where I dwell as an engineer. That's where I sit. I dwell in practicality, hopeless pragmatism. I want to know, I wanted to know in definite terms where that first measurable loss was going to be, because I know that energy cannot be destroyed. It cannot be created. It can only change state. That's it. That's all we have. So if I lost a decibel or two or three or 10, where did it go? What qualifies me as an engineer to keep shoveling more power at something when it's clearly at its limit? And when I started winding compression back in terms of looking at it through the eyes of efficiency, because I've lost energy somewhere, I started to see that there are more and more benefits to avoiding compression. But on top of that, every single speaker on the planet can operate within that limit. You just have to dig and try to find out what's going on. Like in terms of efficiency, one thing that I remember you and I were talking about was speaker cables, you know, switching out a speaker cable. Well, what does a speaker cable do?
Well, I'm in the camp that a speaker cable is like an EQ. It can either be flat, it can accentuate the high frequencies, or it can accentuate the low frequencies, or attenuate either or.
You know why?
No, RLC, but no, I don't know specifically why.
What does that acronym mean? I'm a little old.
Inductance, resistance, capacitance.
Oh, okay. I thought you meant something else. Um, the yes, capacitance, resistance,
And
inductance.
inductance, yes.
The
And there's infinite ways to skin the cat, as they say.
the interesting thing is that if there's a certain amount of capacitance within the speaker cable, if your amplifier is mismatched to your speaker or vice versa, depending on which way you want to look at it and what piece of equipment you want to blame. If they're mismatched and the impedance swing in the driver is such that the amplifier doesn't have enough capacitance to benefit a certain frequency range under certain conditions, a speaker cable with more capacitance acts like a capacitor. And so you can
Okay.
get that energy to benefit a certain spot of your frequency range under specific conditions just by the cable. So yeah,
So does that relate to, can you say that's similar to if your amplifier, you said if it doesn't have enough capacitance, if it's mismatched, can you relate that back to power or your voltage peak to peak?
oh,
If it's not have, if it doesn't have enough jam, then
amperage, amperage.
okay.
If it doesn't have enough amps. So when your impedance rises and falls, what happens is the amplifier needs to generate power, right? So if your voltage drops, it needs to make up amperage. But if it can't make it up fast enough, and your speaker cable just happens to have some capacitance on deck, then it's going to use that capacitance to help itself. It's just
Man, I haven't heard anyone explain why a speaker cable makes a difference like that.
it can.
Just
It's not.
another gold nugget.
Well, that's the thing. It's not a hard and fast rule. It's just it's situational. That's why
Hmm.
some guy is like he'll change out his speaker cables and be like, "Yo, this makes a massive difference." And I'm one of them. I've been down that road with people and I've experienced it and all that stuff. And I've heard speaker cables make a certain amount of difference under specific conditions.
So if your
So,
system is agnostic to speaker cables, is that a good thing?
yeah,
You know, it just means that your amplifier is matched to your speaker.
it's enough so that when you're changing speaker cables, they're not going to make as much of a difference over the length that they're run. So that's the other thing that has to be considered is like how much capacitance does the speaker cable have? How much resistance, how much inductance does like what are its characteristics electrically over the length? And in some
What
cases it doesn't make a difference, in other cases it does. It's so situational, but the less of a change that there is when you're switching out cables, the less of a change that there is, the more closely matched you could say more they're more closely matched your amplifier is to your loudspeaker. And so from an electrical standpoint, it makes perfect sense, but it also lends a lot of credence to the statement that all amplifiers are not created equal. Not all power is created equal. Not all watts are created equal.
mm,
And so there is a shift and a change. I remember when I was young, I was listening to a two-channel tube system and they were changing out a CD player and changing out cables. And they landed on a NAD CD player. And I thought it sounded really good. And they're changing out cables. And I remember thinking to myself, man, like I actually hear a difference. And I didn't know the names of I mean, I was young. I didn't know the names of the speakers that were playing. I just kind of rode up to this hi-fi shop on my bicycle and was hanging out, listening to music because I was just wanted out of the house. And the uh the interesting thing was that I didn't understand that that was happening, but I was a young kid. I've been exposed to loud noises and stuff like that, but I mean, my ears are fairly fresh, like not a whole lot of craziness or age, to dull the hearing or anything. And I was hearing these changes and I thought, wow, I wonder why that is. And I just kind of left it at that. And then when I started to get into amplifiers and speaker drivers and making my own systems, I saw this little correlation. I was like, well, it can be a rule, but it's more of a guide. Like you can say, okay, yeah, if you wanted to, you can say, yeah, this is why. But it's more of a guide because it really depends on how the amplifier generates power. And that's why I've said for years and years and years, the most important part of any audio system, you say it's the human connection, and I do agree with that. I say it is the amplifier in terms of equipment, because the amplifier has a brutal job. It has to take a tiny little signal, make it huge, and then react to all the data and information and frequency changes and modulating and impulses and amplitudes and everything. And it has to do it on two levels. It has to do it on the signal level and it has to do it on the high power level. And then it has to deal with whatever is coming back on the negative leg from the speaker. So when it gives energy to the speaker responds, reacts, does its thing, and then whatever's left over either gets shorted through the shorting ring or comes back on the negative leg. And then the amplifier has to basically balance itself out so it doesn't die, it doesn't blow up. And that's kind of the short strokes there. But that that little picture, it would be so ideal if every amplifier was created the same, because then it's so predictable. But it's not that way. We've got a consumer market, the
Yes,
economic
we
side
do.
there. Yeah.
Um, I we have no time limit here. I do want to be cognizant of time. I have a very interesting closeout observation, but if there's anything else that feel you want to throw in, please by all means go ahead.
Um, I think that when it comes to audio, like I'm just gonna do some closing remarks. We can edit this little chunk. Um, I think that when it comes to audio playback, the freedom for expression is paramount. You should be allowed to do whatever you like that brings you joy and brings you contentment. When it comes to the pursuit of fidelity, it's very easy to channel it into compression. And I think that using compression as the barometer for fidelity, because understanding that compression within the speaker driver is the inability for the driver to articulate and to create detailed sound where it's literally losing steam and can't get out of its own way. That is a great metric for fidelity. And so that's what we pursue. We pursue it in our bass systems, we pursue it in our loudspeakers. We That's our direction, that's our directive. And so I don't know, I think it's interesting listening to your content where you focus on the human connection, where it's easy to listen and understand what you're taking in, where you're happy, where things make sense. And efficiency is what was what the human brain wants to do. It wants to understand its environment. It wants to understand what it's hearing, seeing, all of those things. And so I think compression, that loss of energy, inefficiency is an absolutely bang on marker if you're looking for fidelity. It just fits. It fits so well.
Cody, I don't think you have to edit anything about that. That was extremely well articulated and a great closing. I I just want to say, where can everyone reach you? Just share that again with our listeners.
Our website is www.harbottleaudio.com, and I'm available on WhatsApp. It's a fairly good messaging service. And then we have our social media links at the bottom of the landing page, on the bottom of every page on the footer. So we got a lot of social media links as well. I'm available through pretty much all of those. And email, of course, harbottle.company@gmail.com. And yeah, and you can feel free to call, text 604-341-6875. That's my phone number, direct line to me.
Nice, that's awesome. And I am Scott Lylander. You can find me on social media at audio_acoustic_engineering. You can go to my website at aaeaudio.com and or just search for Scott, or my friends call me Scotty Lylander. And in closing, all I gotta say is that I wish every speaker review would have an in-depth discussion with the speaker designer on what they intended their design to do with the review. Oh my God, wouldn't it be such a perfect world? But yay, the world is not perfect.
Yeah, that would be absolutely deadly because it would clear up so many things. I agree with you wholeheartedly.
And hey, just in closing, are there any speaker parameters you would want to see published as a normalization? Speaker cable parameters.
Speaker cable parameters?
Yeah, are there any, would there be any normalization
Um,
in
not
specs?
not really. I mean, like just as far as standard measures, I would say resistance per linear foot, or total resistance if it's pre-manufactured, and capacitance per linear foot or capacitance per manufactured length. Those two would be pretty good. Inductance definitely, yeah, because I mean inductance, that's like a high pass filter and a crossover. So yeah, those three are are pretty good. I mean, if there's a standardization metric that they could use. Um, as far as speaker parameters go, I would really like to see voltage published as as a standard, both on amplifiers and loudspeakers, even if it's just you know voltage peak to peak or voltage RMS, something that indicates the most constant energy source within an audio system. The thing that really doesn't change that much is voltage. So I think that would be a really good thing to reference.
Nice. Well, viewers, friends, this is Cody Heibert with Harbottle Audio, and we're signing off for tonight, but I guarantee we got to continue this type of conversation. This was excellent. Thank you, Cody, so much, and we'll see you in Edmonton.
Thanks, Scotty. I appreciate it, man.
Right on. Cheers.
Cheers.